Hello and welcome to Beginners Python and Machine Learning. My name is Tim Cummings. Tonight we're going to be looking at two dataframe libraries that people can use, and Pandas, which is the very common one, and Pandas, which is a high performance one for people who are using large data sets. So in Beginners Python and Machine Learning, we try to help beginners get into Python, and we also look at topics that might help them in machine learning, as well as other Python topics. So tonight we're going to be using a Google Colab notebook, so you don't need to have Python installed on your computer. And I've got a link. If you look below the video, in the description of the video in YouTube, you'll see a link to Google Colab. And if you are looking at the meetup page, then you'll also see that same link. So I'm on the meetup page now, so I'm going to click on the link. That's going to take me to Google Colab, where you'll see the notebook that I set up. Now I recommend the first thing you do is copy this to your own drive, and that way you can make changes and save them and refer to them later. So I'm going to click on copy to drive, and you see down the bottom left it says it's creating a copy. Open a new tab. Alright. So Google Colab gives you a virtual private server that you can run some Python on. It's just a Ubuntu server, and it's got a whole bunch of Python libraries installed. I think it's pretty close to the Anaconda install, but with a couple of extras as well. This is a live stream, so the idea is that you ask questions as we go along. You can ask on YouTube chat or in our Slack channel. So this is Beginners Python and Machine Learning, which you can't see, and Learning to Code is the channel that I'll be watching tonight. It's a repeat of the presentation I did at Amazon Web Services venue in Brisbane last week. So if you didn't make it to that, you can now get to see it here. And if you did make it to that and you've got any questions, please feel free to ask. So I'll just dive straight into it. If you have any questions about using Colab Notebook, ask questions as well, but we've covered that in other days, so I'll presume that you know it at the moment. Now, to run bash command line instructions in Google Colab, you just put an exclamation mark at the front there, and so we're going to use pip to just see which libraries are installed. Now it's got a whole bunch of libraries installed, so we'll just filter them out on all those that have got either the word polars or pandas in them. And so if I run that, we'll see that we've got pandas version 2.2.2 and polars 1.9.0. So they're the important ones that we're going to use. So we're going to start using them by importing them first and just using conventions that everyone else does. When we import pandas, we import it as PD just to save on typing, and polars will import it as PL. Okay. We'll also import time. I don't think I use it actually. I set that up for doing some timing comparisons, but my data sets were too small, and so it was they were finishing too quickly for it to be an accurate time measurement. So I was getting like factors of 4 in the time difference between running the same command. So it was obviously caching stuff. And anyway, we won't worry about timing, but we're going to grab some data from the Brisbane City Council open data set, and you can go to this URL here to look at more information. So this is using information about their public art that they have in their portfolio and whereabouts it's installed around Brisbane. So I've got a URL for collecting the art in a CSV file, so I'll just include that here. I'm also going to grab some extra data sets that are a little bit larger, cycling using bikeway counts and traffic management. And I'm grabbing them as Parquet files rather than CSV. I haven't used them before, so they should be interesting. They're supposed to be just slightly more performant than CSV files, and they're handled equally well by Pandas and Polars. So I'm going to go to each of those URLs using the requests library, and I'm going to save them as a file. So bccart.csv, bcccycle.parquet, and bcctraffic.parquet. So I'll just run that to go to those use that web API to grab those files, and they're just going to be stored. If I click on here, we'll see we've now stored those 3 files that we can create data frames from. In fact, I showed you how to look at the files icon here, or you can run ls-l to see the files, and this tells you how big they are as well. So the cycling file is the biggest one, traffic is next, and then the art one is the smallest. So first of all, we'll have a look at Pandas. Pandas, we want to read a CSV file, so we'll use the read CSV method. Now that function will actually, we could pass it a URL and we go straight to the website and grab it, or in this case we're going to give it the name of the file, and it'll pull it off our local storage. Now Polars doesn't give you the option of just putting a URL in, so you have to load the file. So in this case I thought, well, I'll do it the equivalent way of both, but if you do want the functionality of reading it straight from the URL, then Pandas is the one you want to use. So you can see that the data file that we've got here, this is all the columns can display here. It's got a column called index. Now that's part of the Brisbane City Council data file. It's a 1-based index, so 1, 2, 3, 4, 5. But Pandas actually adds in an extra index column at the beginning, 0, 1, 2, 3, 4. And there's nothing else. So you can see that the data is a mixture of text and numbers. So we've got integers and floating point numbers, and even a geolocation. So let's try the same thing with Polars. There's a read CSV method. We'll call that and run it, and you can see it looks pretty similar. Now when we display Polars information, I've displayed it here. I could have just said DFL art, so the L for Polars, dataframe, Polars, art. I've just done head. I could have left the head off and it would just show me the top 5 and the bottom 5 rows. But it also shows me a little bit more information. It tells me the shape. In fact, I'm going to get rid of the head here, because that way the shape will tell me how many rows in the full data frame. The 14 tells me the number of columns. If I look at the columns, I can see it actually tells me the data type. So I've got an integer, string, integer, floating point, and these geolocations are strings. And notice it doesn't have an index provided by Polars like Pandas did. It's only got the index provided by the Brisbane City Council. So there's one difference. Now Polars, as well as having a read CSV method, it has a scan CSV method, and this is a lazy method, and the Polars people say use lazy whenever possible, because it can optimize if you do things in a lazy manner, and then it will increase the speed and save on memory usage and things like that. So to do the same thing we do scan CSV and the file name just as before, and by calling that method, it doesn't actually read the CSV file. It just stores in memory that you want to read that CSV file, and then you can say, well, I want to do something else to it. I want to filter it just on anything in the material column that is equal to bronze. And up until there, it's all just lazy. It's just keeping a record of what you want to do until you say collect. And when you say collect, then it converts from lazy to eager, and it will do what you've actually asked. So if we run that, and you can see it's pulled in the bronze ones, and by doing it in this way, when it's read in the file name, anything that didn't have the material bronze, it didn't even store in memory. It just left it to it just ignored it from the file, and so that's where it's going to improve your performance in that sense. But in this case, we do actually want all of the data that we're going to be working with, so I've just stored that into a separate data frame for now. Let's try the same thing with our Parquet files for the cycle data. So in this one, this is Pandas. DFD cycle is the Pandas data, so it's got an additional index. We've got a date, and then we've got a 001, how many cyclists, pedestrians, a 002, cyclists and pedestrians, 003, cyclists, pedestrians, etc. And in A004, I think these are intersections or something. There's an east version of it as well. We look at the data, we can see there's lots of NANs, not a numbers, so that must be just missing data in the data set that we've read in. Maybe the cycleway didn't exist back then, or the counter was out for some reason. Okay, and if we want to have a look at the polars data, let's just type in the polar name, and we'll see it's got 1,826 records, 76 columns, and we can see the data types. No index column as was inserted here for the Pandas one, and you can see the different data types, and here we've got I64s, and where the missing data is, it's just put in a null. So there's a little bit of a difference to how it's handling the data. If we look over here at A004N, that one's a string for some reason, so these numbers have come through as strings, and I'd say that that's because, as well as having missing data and integers, it's probably got some text in there, so it's had to convert the whole column to string. Right, so we'll go back to our art one. Now, to make it easier when I'm comparing some of the selection methods in Pandas, we're going to set the index to the Brisbane City Council index rather than the automatic one that was created by read CSV. So there we go, we can now see the index, and it starts from 1 rather than 0. And this will just make it easier because some of these methods go on row numbers, which is always 0 based, and others go on the index values, which is now 1 based, so they'll be different. Okay, now one thing you might want to do with a data frame is grab a single column. Now we've got a column called item title, and we can select that just by putting the name of that column into square brackets for the data frame. And if we do that, let's store the result in a variable called SD, and you can see that DFD art is a Pandas data frame and SD is a Pandas series. So that's why I called it SD, because I knew it was going to be a Pandas series. Now if we look at the series in Pandas, we can see it's got the item title column that we've selected, and it's also brought across the index, so we can when we're working with this series, we can use the index for particular things that we might want to do on the series. In polars, if we try doing the same thing, the same syntax will actually work in polars. So square brackets, name of the column inside the square brackets, store it into a variable, and check what the types are. It's all exactly the same syntax. We can see that we started with a polars data frame and we finished with a polars series. Now if we look at the series, we'll see it's the item title, it's got the same names as before. It tells us that this data type in the series is string. We've got 186 rows, so we're telling it a bit more information just by displaying it, but no index. So once again, polars doesn't have an index. They also, polars suggests that you use select rather than square brackets for selecting a column, and when you do that, you'll get slightly different result. You'll get, rather than a series, we'll get a single column data frame. Not really sure how that's going to change things, but I've often wondered what the point of series were, because they I would be quite happy myself just using single column data frames at all times. Right. Now, if we want to get a sub data frame from our main data frame just by taking a few of the columns, we can supply a list of column names inside the square brackets. So you can see I've got a list here with the green square brackets inside the blue square brackets, which is the selector for our Pandas data frame. So if I run that, I get our 3 columns, all looking good, and once again I get the index. Now that same thing will work in polars. Once again, no index, but I do get item title, latitude and longitude. And that same thing will work with the select function, which uses the expression API. So this is what they recommend for better performance. And obviously the data set's too small for us to actually tell the difference now, how that would make a difference, but possibly in big data sets that would. So a fun thing to do with Pandas data frames is plot your data. So I'm going to plot the latitude versus longitude for where the locations of the artwork is around Brisbane, and I can just do that using the plot method on the Pandas data frame object, and I've put in a size and an alpha. So that just uses matplotlib to run this command, and matplotlib does need to be installed, but it is already installed in Google Colab. And so you can see roughly just where all the artworks are scattered around Brisbane. Now if I wanted to do the same thing in polars, polars rather than using matplotlib, it uses Altair, and it uses Altair version 5.4 or greater. So if I want to see if Altair is installed on Google Colab, I can see it's only version 4.2.2. So we need to install Altair, and well, we need to upgrade Altair, and we can do that just using from the command line pip install -u for upgrade Altair. Now if you've gone on further and actually used Altair before you upgraded it, then you're going to have to go back and restart your whole session, but we haven't used it yet, so we can just upgrade it now and it should start using it. And it's installed version 5.5, so that's greater than 5.4, so that's good. So the command is slightly different here. Remember we did just .plot and then ran that as a function. In here we use dfl .plot, and it creates that's an object that we then call the point method on to draw using all our x's and y's that we've got out of our data frame. But when we look at it, it doesn't look too good because it's a zero-based plot, and so Brisbane, all the different coordinates are around here in Brisbane, and there's, you know, that's the other side of the world, and there's up at the equator. So we need to tell Altair not to do a zero-based plot. So we have to provide a bit more information, which means we need to expand out the parameters of point, and I looked up the Altair documentation on how to do that, and rather than just say x equals longitude, I can say x equals, and I can say an Altair.x, which has got taking the column longitude from our data frame, and it's scaling without requiring 0 to be in the graph. And similarly for latitude, and I also thought some of the other things you could do is like add tooltips, and that's pretty easy. I just said which columns provided the tooltip information, and when I ran that, now I can see they're all scattered around properly, and when I hover over any of them, it tells me through the tooltips what the item title is, where it is, what material it's made of. Alright, well that was fun. Okay, selecting data in Pandas. So I'll just go over a bit of a refresher for people who are new to Pandas, and this is a beginners group, so that could well be all of you. There's different ways of selecting data. We can use these methods. So we've got at and lock. So at, we can specify a single row and a single column, or lock, we can specify a list of rows or a list of columns if we want multiple elements. So these are all based on so the row you specify by the index values, so they can be strings or dates, or in our case they are integers, but they're the new integer column that we've added from the Brisbane City Council, so it starts at 1 rather than 0. Columns are the column names for each of the columns in our data frame. There's also an equivalent IAT, which we can put in an integer row number and an integer column number, and these are zero-based integer indexes, and so that's why we changed the index before, so that you can tell the difference between how IAT works and how at works and how ilock works and lock works. So let's have a look at an example. We want to find the single data element that's at row with index 5, and I didn't want to do that, so let's move that back and maybe move it over to here. And it's in the column item title. So if I run that, we get progress of civilization. Similarly, I could have done the same thing with lock, just row 5 and item title, and it gives me the same progress of civilization. Or because lock can take multiple rows and columns, I can say provide 2 rows and 2 columns, and so I get index 4 and index 6, item title and material, and I'll get a sub data frame that way. Or in fact I can use slicing, which is particularly useful. So you can do a slicing all the columns between item title and material, so it's item title, title list, artist list, location and material, and the index from 4, 5, 6 inclusive. So it's a little bit different to normal Python slicing in that it is inclusive of the final part value of the slice. Okay, so let's look at using IAT and ilock to do similar things. So item title is the 0th column, and we wanted the row with index value 5, so that's actually row number 4 if you started from 0. So it should give us the same thing, progress of civilization, and that's using iat, and the same thing using iloc. Once again, we can do slicing. So you know this now we're doing slicing. It's and we're working with integer values of rows and columns. Now it's doesn't include, so this is now the typical Python behavior. It doesn't include the final value, so it's not including the 6. It's using, this is row 4 and row 5, which is confusingly index 5 and index 6, and it's columns 0, 1, 2, which is 0, 1, 2, and not including 3. And the reason they do that is if you want to know how many columns you've got, you just say 3 minus 0, I've got 3 columns. And if you want to know how many rows you've got, it's just 6 minus 4, which equals 2. Another way of selecting an item is you can select the whole column, doing that way, and then you can select index value 5 from that series. So yeah, selecting the columns gives you a series, and then you can just do index value 5 to get progress of civilization. So just another way of selecting data. So I'm concentrating here on Pandas. We can do filters as well. So for example, I can create a filter by saying dfd art material equals aluminium, and then from that I can say just give me the column item list title list, and I can even set that to a value. So let's have a look. What is this doing? No, that's not what I wanted to show. So when I create a filter like this, it creates a series of trues and falses, and then I can apply that into the square brackets for DFD art material. Then I can do this one. So if I put that series of trues and falses inside the square brackets, then it will just show the rows that have got a true in that series. And then that's, as you can see, they've now all the aluminium material ones. So from that I could select a particular column and run that, and there's the column of everything that's in aluminium, item title list. And what can be tempting to do in Pandas is then assign those values. Say you wanted to change them to something else, and I've got an example here. I want to change them all to a aluminium sculpture. What would happen? So let's run that. And sometimes this will work and sometimes it won't, but every time it will throw an error, or not an error, a warning. It's called this setting with copy warning. So if you do get this setting with copy warning, even if the data is correct, it's best to work out why you've got that problem and try to work out what you need to fix it. So it tells you a value is trying to be set on a copy of a slice from a data frame. Try using .lock row indexer col indexer instead. And if we look at our item title list, we can see that none of them have changed. So in this case they didn't change, and so we definitely have to do something about it. If if they had changed, we still should do something about it. So the correct way would be to do this. So let's get rid of that line. And that's how you do it using lock. You don't get the warning, and you can see our item title list does actually change. Okay, so that was a bit of a crash course in Pandas and how to select data and modify data. Now let's have a look at doing a similar thing in polars. Now there's no X index in polars, so there's no lock or iLock method in polars. There's also no setting with copy warning in polars, because you can't actually do the command that could lead you into a false sense of security that it could work. So selecting a column in polars, we've done that before. We can just select item title, and there it is. Similar to iLock, we can select on rows and columns and just do that in our square brackets. And here we're just using zero-based indices. So 4 to 9, that should be 5 rows, and 1 to 3 is 2 columns. We can do, if we just put a single number in there, then that gives us the 4th row, starting from 0. So it's the one with index number 5, where index is the BCC, the Brisbane City Council supplied column. So if we want to use, so in Pandas we had a .lock to access a single data element, such as that. We just did 5, item title. So if we wanted to do that in polars, we can take our polars data frame. We can run a filter on it to say we just want the row where the index value is 5, and then we want to select the column item title, and then tell us what that item is and its progress of civilization. So if that's what you want to do, then the polars syntax is a lot more verbose than the Pandas syntax. Possibly it's a bit clearer about what's going to happen, but yeah, it's going to take more typing. If I didn't put the item on the end here, it would actually give me a data frame, 1x1 data frame. But if I pull out the item, then it just actually selects the element out of that data frame, and it's that string. Okay, so that was equivalent to data frame lock. Now if we wanted to do equivalent with a sub data frame of rows, we could do this sort of thing. We want index to be between 2 and 5. And when you do that, when you use isBetween, then you've also got the ability to add this third parameter to say closed is either left, right, none, or both, and by default it's both. So by default we got 2 and 5 and everything in between. But if you wanted to be more Pythonic, you'd choose left, where you'd get 2, everything in between, but not the final one. Okay, so let's have a look at column names. In our Pandas data frame, the columns are stored as an index itself, so anything you can do on the row index you can do on the column index, but in polars they store them as a list, and so that's actually easier to work with for people who just know Python and aren't familiar with what an index can or can't do. We all know what a list can do, so in that sense, if we want to find out which column number it is that we want to do something with, we can use the index method on Python list. So that's a standard Python function not anything to do with polars, but we can use it to say find our start index for the column number, our end index for the column number, and then we can use the syntax that we had before, where inside the square brackets we just put integer colon integer for the rows and integer colon integer for the columns, and in this case the rows we want all of them, so we just leave the blank before and after. We've added 1 because we want it to be inclusive at the end, and by default Python doesn't include it. And we get all the columns from artist to material. So we've had to do 3 rows here rather than the 1 row that we had in Pandas. So it's not looking too good for polars at the moment, but I think polars will really shine later on when we get to see some of the things you can do. If you want to use select, we can get the list of columns from our data frame just using the columns property, and then slice it using those column numbers and put it through select, which is going to give us very similar thing. So in this case we didn't need to specify that we wanted all rows because select automatically does that for us. Both in Pandas and polars you can select columns using regular expressions, and they're pretty similar, so not much really to differentiate them here. That's the Pandas one, and that's the polars one, and just what I'm trying to do here is pull out every column that's got the word pedestrian in it. So it's ignored the other ones which had and I can't remember what the others were. Anyway, it's not important, but cyclists, I think it was cycles were the other ones. Yep, there's what we've done. Okay, let's have a look at our data frame to remind us of the art one. I've already talked about a list of bools for selecting rows, and we did an example of that before. There's another example, so you can see it's selected 1, 2, 4. So this is for columns 1, 2, 4. So that's item title list, and artist list. So we can create a list using an expression. So we want to find every column name that's got a space in it. So this is the Pandas version, and put them together, we get all the columns there in the data frame that have got spaces in them: item title list, artist list, and suburb list. And what's special about this? It's just another way of doing the same thing. We can grab the columns and that returns a list, and we can supply that list as inside the square brackets. Same thing again. So there's just a lot of variations of doing similar things, so that you can have a look if there's something that one of the methods doesn't quite work for you. You can try another one, and Pandas has just got heaps of them. So for example, we want to filter on rows. We want everything that was installed in 2023 or later. We can just put our filter inside the square brackets and use .lock. And if we look at the year installed 2023, and that's all we got, just the 3 of them. So that's using .lock. This is just using the square brackets directly and supplying a list of rows. So it looks very similar. Okay. Now we're going to look at traffic data and some of the things that we can do on that. So we're going to And the reason we're going to use the traffic data is it's got more numbers in it. So we can start doing calculations on columns, which is a really powerful feature of Pandas and Polars. So we'll work through the steps, and you can see what we can get out of it. So first of all, we'll read in the traffic data, which is a Parquet file, using read Parquet, and it reads it straight in. There's 1260 entries, and these are the data. And you can see it's given us here, by calling up info, I can see what data types they all are. So it's got a site ID, which is an integer. It's got a year, which is an object for some reason. It's got the month, which is an integer. It's got all these numbers of average, weekly, daily traffic, vehicles, hours, AM peak. So this average number of vehicles per hour in the morning peak hour between 7 and 9 AM. Average number of vehicles per hour in the evening between 4 and 7 PM. It's got a travel time during those peak times, and it's got the speed of the traffic. Now, these objects are strings for some reason, so that's not really useful to us. We like integers and floating point numbers if we want to do arithmetic on them. So what we can do, in Pandas, we can say, well, give us all the columns that are objects, and I want to try to convert them to numeric numbers using this function here, pandas.toNumeric. And if there's any errors, then do coerce, which means force it to be a numeric number, but if you do get an error, then it becomes not a number. And the reason we've got these problems here is because Brisbane City Council have, in the data, rather than just leaving the data blank, they've put in the two characters NA. So by doing this, when we get, that's going to throw an error for us, and by using coerce as to how to deal with errors, then it's going to convert it to an NaN. The other thing that I want to do is, and Leo said thanks, that's great. See these column names, they've got underscores in them, and when I display a data frame with columns with underscores in them, they get very wide because it doesn't like to put breaks in that column name. So I want to replace all these underscores with spaces. So I'm going to do that. I'm going to find all the existing column names and then create a new dictionary that takes the old column name and puts in the new column name, which is the old one with underscores replaced with spaces, and then call the Pandas function rename to use those new names. And I'm also going to set the index. As you can see, there's got a column called index. Alright, so let's run all these commands and see what our new data frame looks like. So the info now tells me I've got integer, 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 float, 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 integer, integer, float, float. I look at the data. It does look like integer data, but it is floating point for these, and that's probably because there's some not a numbers in there, and they're they have to go in as a NumPy float 64 to handle that. The NumPy in 64 can't handle not a numbers, or doesn't have that as a type. Okay, and you can see I've got these column names now have spaces rather than underscores, and they fit more nicely on the page. Now if I was to do the same thing with Polars, I'm going to use scan Parquet rather than read Parquet. So it's a lazy reading of the file. Then I'm going to say I want the columns, any column that's a string, I want to cast it to integer, and strict equals false. So if it's causes any problem by doing that, like it comes up with an NA or the data's missing, then it's just going to put a null in place. I can use the same new names dictionary that I had before to rename the columns, and then I'll convert it to an eager because I want it to happen right now by putting collect after it's done all these other things. And I've put the whole lot in parentheses. Really the only reason for doing that is so that I can, when it gets to the end of this line, Python realizes that it continues on the next line, and that this dot with columns is as though it was typed up here straight after the scan parquet. So this is pl.scanparquet.withcolumns.rename.collect. And then I'll have a look at the schema once I've done all that. So this is good. It's all coming as integers. Every single value here is integers except the speed. So I've got more integers this time. And I've got some floating point numbers for the speed. If I look at the data, it's all looking pretty good. All integers here. And there's probably some nulls in there where the NAs were. Okay, so in Pandas, let's do some calculations. So we can just take a column, divide by a scalar value, so scalar meaning a single value, so 24, and it will go through every row in that column and divide it by 24 and create a new column, and we want to call the new column volume per hour average. So let's see how that works in Pandas. This is a really powerful feature of Pandas. And you can see here volume per hour average 2997.79. Each one of those is the volume per hour, the average weekday daily traffic, which is this first column, divided by 24. So that was a fairly simple calculation. Let's try to do a more complicated one. So this time we're going to try to calculate the average travel time in peak hour in seconds. So we've got the travel time in the morning and the travel time in the evening. So we want to do a weighted average of that. So we need to look at the number of vehicles in the morning and the number of vehicles in the evening. We weight those travel times by the number of vehicles and then divide by the total number of vehicles. So that's a pretty complicated expression, and it's doing that so it's taking one column of numbers, multiplying by another column of numbers. So in that sense, it takes the first value in each column and multiplies them together, and that becomes the first volume in a new column. And then it takes the second value by second value, becomes a new second value. So it does that, then it does the same thing here for those multiplications, then it adds those and creates another column, and then divides by these two columns that it's added. So I'm just really impressed when I see Pandas do something like that. And there we go, we've got a new column, average travel time peak hour in seconds. And I couldn't believe that it got it right, so I've done some, well, first of all, let's just have a look at month equals 5. Yep, and then I've done some, check the site data for site ID 1 in May 2024. So that's this one up here. It comes up to 470, and I just put in the numbers. So 489584 times 529 plus 4557 times 407 divided by the sum of those. What does that come up to? And it should come up to 470 if we did it right, and it does, 470. Still didn't believe it, so I ran an assert on that, and yep, still comes to 470. So very clever. And just to keep you on your toes, different ways of selecting the data. In Pandas, you can do a query where it's just like a text-based thing, you'd do in a database, and once again, you get the same results. So how about if you wanted to calculate the sign of a value? So up here we were just using operators, let's see now. Here we use, these are all operators, so you've got asterisk for multiplication, plus for addition, slash for division. And Pandas can just override operators in Python when it's dealing with objects and give them a new meaning. So that's how it's implemented that. But say we want to do sign of a value, that's calling a function which is designed to be run on a single scalar value. So Pandas can't override that. So if I try running this command here, I'll get a problem. It says must be a real number, not an index. So I'm just going to comment that out because I don't like having commands that are going to fail inside my workbooks, in my notebooks. So the way to get around that, fortunately NumPy does provide a new version of the function, so np.sign, that can work on a column of numbers, and so you can use that if you ever want to do a function. You just have to make sure that NumPy is providing the function that you want to call. And there it goes, it works. So if you look in the last column over here, sign index, and there's a sign of all the values in the index. That is actually the index in Pandas. If you want to work with dates and times, then Pandas has a toDateTime function, and so in here I've converted it all to a string that's in the format 4 digits for the year and 2 digits for the month, and the toDateTime will convert that to a string. So let's try that out, and we'll put it in a new column called year month, and you can see here year month on the right hand end is 2024-10-01. So they are date times. So now we can do date time arithmetic if we need to in our Pandas data frame. And there's a reason I'm doing all these things. So say we wanted to filter out anything earlier than 2021, I can grab the year column, and anything greater than, I only want to include things that are greater than 2021. So if I run that, we've now got a lot fewer years, and 2021 is the last one. So these are a whole bunch of steps that you'd possibly do if you're processing, cleaning up your data, ready to be used in some sort of machine learning thing. And we're just working through them step by step. So another thing I want to do, rather than this site column, which is just 1, 2, 3, I want to give it a name. I want to call it SITE space and then a 2-digit ID. So I can do that just by using these functions. I do a 0 fill, 2 digits on the ID, and add the word SITE at the front. And there you can see site 01, site 02, site 03. And I'm wanting to do that because later on I want to create column names based on the sites and doing a pivot, and they will look a lot nicer than just the numbers 1, 2, 3, 4, 5. And here's the pivot. So I'm going to pivot on site name. I want to look at the values for travel time, and the index is going to be year month. So here you can see the column names, site 01, site 02, site 03, so they look nice. The index column is now called year month on our Pandas data frame, and the column index is called site name. And all the data here are all the travel times that we've calculated. So that was a really quick rundown on Pandas, and you can work through some of those examples and try to understand them a bit more. But really what I've done is create a series of steps that I now want to repeat in polars. And so I'm going to use lazy frames, which is the lazy way of Polars, so it doesn't actually work out anything until it becomes eager. And I start with scan Parquet, which is a lazy way of reading in a file, and I store that into a lazy frame. Now I could do what I did before, which is have parentheses before the beginning one and parentheses after the last one, and then have all this as like one big line, and just have pl.scanParquet.withColumns.rename.withColumns. Or in this case, I'm going to show you that you can actually just store the intermediate values in a variable, because you might have them in different cells, or you might have some conditional code in there that you only want to run with columns in a particular instance. But anyway, we'll create all the steps that we want to do. So, and we'll store it all in a lazy frame. So I'm going to read in the Parquet file. I'm going to convert everything to integers. I'm going to rename the names to not have underscores in them. I'm going to add in a column, which is the volume per hour average, which is just dividing 24 into the average weekday traffic vehicles per day. I'm going to do that even more complicated weighted average of working out the travel time. I'm going to find the sign of the index. In this case, I'm using the polars. I've got the sign function rather than the numpy sign function. I'm going to convert year and month to a year, month, date, time. I'm going to do a filter that's going to filter out anything. I only want the things that are greater than 2021. I'm going to rename my site column. So these are all things I've just done to the Pandas data frame, and I'm just putting them all in a list of things here I'm doing to my lazy frame in Polars. So I'm padding with zeros, so it'll be site 01, site 02, and that's going to be a column called site name. I'm then going to just select these columns: year, month, site name, and travel time. And I'm going to sort on year, month, and site name. And then I want to create a pivot table. Now, creating a pivot table, I can't do that with a lazy frame. So this is all the stuff I can do with my lazy frame. So if I run this command, I can then look at what gets stored in the lazy frame. And here it is. So it's the naive query plan. And it gives me a hint up here. Run show graph to see the optimized version. So this is the non-optimized version. These are all the things it's going to do that I've just asked it to do. And for some reason it does the bottom one first. So I'm going to scan in the, I don't know why that's, all right. I'm going to scan in the Parquet file. I'm going to cast to integers. I'm going to rename the columns. I'm going to do some calculation of the average volume per hour. I'm going to calculate my weighted average of travel time. I'm going to, what am I going to do here? I'm going to cast index to a float and calculate the sign of that value after I convert it to radians. I'm going to calculate the year-month column. I'm going to filter out everything that's before 2021 and just leave everything after. I'm going to create a site name column, and then I'm going to sort by year, month, and site name. So it's all ready to do my pivot. So that's the non-optimized version of it. Now let's have a look at the optimized version. So it's analyzed all those steps and worked out what we really need to do. And here we go. So it starts off with reading the Parquet file, but it's worked out that I only need 7 of the 11 columns, so it's not even going to read the other 4 columns. So there's an optimization right from the start. Once it's done that, it's going to cast them to integers, but of course it's worked out which only the columns that I need to do that. Then it's going to do the filter. Now, we didn't tell it to do the filter until a lot later, but it's worked out that it can actually do the filter earlier, and if it does it earlier, then it's going to be a lot less data that it needs to work on, and sort of save in memory. Then it can do the rename. Then it can do the calculating the weighted average calculation. Then it simplifies it just by taking the 3 columns that we need and sorting by those. So it's realized it doesn't even need to calculate the sign of the index because we didn't actually use that data anywhere. So it's just going to ignore that step. So we've got fewer steps to do, we've got fewer data to do them on, and so it can be all optimized. So that's a graphical way of viewing what's going to happen. You can also look at it in a text way, which is probably easier to read, in truth be told, by using lf.explain, and there it is. That's the same thing that I've just said. So now we want to do it. So none of that has actually happened yet. So I do the collect function and I store the result from collect into a data frame. So this is a lazy frame, this is a data frame here. Let's have a look at it, and you can see it's pretty similar data to what we did after all those steps in Pandas, but it did it a lot more efficiently because it only had to do it on some of the rows and it didn't do the intermediate steps that we didn't need to do. So now I can use pivot, which was the eager function, and that will show up in the same way as the Pandas one. Alright, so I hope you've enjoyed that. Polars is a fascinating library. It's always interested in performance, and I think the Pandas people are watching what the Polars guys are doing, because one of the things that Polars did was it used, rather than using NumPy data formats for storing data, it used the Apache Arrow project to store its data, which is very good for large data sets. And recently Pandas has decided, well, then they're going to do that too, and that was the big change that went from Pandas 1 to Pandas 2, was to use Apache Arrow data for storing the internal data in Pandas. Polars has got functions for converting straight to a Pandas data frame if you need to, or you manage to find something in Pandas that Pandas can do that Polars can't do, and then you can easily convert it back to a Polars one if you want the performance improvements that you get from that. So I hope you find that interesting. This is probably going to be our last presentation before Christmas, so probably late January we'll start up doing them again. We've got no questions so far, but I hope you found it useful, and I'll see you in the new year.